Greetings and welcome to a video about functions in Python. So what do we use functions for in programming? Well, they're to compartmentalize or group together sequences of operations. A more technical way of phrasing that, I suppose, would be a function's purpose is to transform data. You put data in, data gets transformed, and you get the data out. But conceptually, really, what we're doing is we're taking groups of operations that belong with each other and bundling them together. So that way, when we need to do that thing, we just call that function, and all of those related operations are already nice and bundled together and ready for us to use. This is called modularity in programming lingo and also lends itself towards reusability. For example, we don't want to have to go through the steps necessary to convert a string to a number ourselves every time that we convert a string to a number. We call the int function to do that conversion for us. I don't want to have to go through the hassle of grabbing the console, putting out and pushing output to the console manually, a character at a time. Every time I want to print something, I'm going to call the print function. Somebody already else wrote that, and I can reuse this function. So modularity and reusability is why we use functions in programming in general. Now, I do want to take a quick moment here to talk about the concept of reusability. You'll encounter this a lot, especially once you start entering in the discussion of object-oriented programming, where like the whole goal behind programming is to write a function once and then reuse that function throughout all of your code. You know, the holy grail of reusability. That's not really what you're going to be doing 9 times out of 10. There are scenarios where you want to write functions and modules and classes and so on and so forth as general as possible, as flexible as possible to be used in many different applications. Generally speaking, you're doing that because you're writing something for other people to use. You're writing your own Python module. You are writing an engine or an application to be sold to people that is intended to be expanded upon. You are writing an enterprise grade software solution that's intended to be used by many different departments within a massive company. These are not normal scenarios. I will tell you from personal experience, I have almost never reused any of the code that I have written, both as a, personal, on my personal programming projects and in commercial projects. Literally the only time that I've ever reused code is in the educational setting, reusing code between classes. That's not to say reusability is bad. I'm just saying don't stress yourself out trying to write hyper generic code that you can use from project to project. If it happens that you can grab a function from one assignment and use it in another assignment, which would in fact be the case with this function here that we're going to go over, great, that's awesome. But don't worry if you can't. Okay. So what is the syntax of a function? What does a function look like in Python? Well, apologize for the coughing. Start off with, you have to define your function or use the def keyword. That has to be the first of the line. So we've got def, function name. Function names follow variable naming rules. So first character is a letter or an underscore, and then the rest of the characters are alphanumeric or the underscore. Nothing else is allowed. You then have an open parentheses. Oops, that's not what I wanted to do. You then have an open parentheses, a comma-separated list of variables that you want to pass into the function. We'll talk about that in a moment. And then your closing parentheses. You do not have to have parameters or information that you want to pass into a function. Down here in this def main that I have written, you will notice that there is nothing inside the parentheses. This is perfectly okay, and it's relatively common to have functions that do not take parameters being passed into them. Again, yes, we have the ending colon here to indicate that this line is done. And then, as always with Python, we have indentation levels that determine what belongs to this function. You can see here the helpful guide from Visual Studio Code. This line here indicating that this block here belongs to the function, because as soon as it hits this line here, which is at a different indent level, it's like, oh, nope, okay, we're done. This does not belong to that function up above. You are going to want to define your functions before you use them. So that is why I have my functions listed at the top. And then code outside the function listed down at the very bottom. Exactly what can go into a function is entirely up to you. It's just regular code at that point, just kind of like if statements and while loops. Once we've defined the function, we just put in the code that we want to run. When I call this function, it's going to start off with this line, go to this line, so on and so forth. It'll do the while loops. As you can see, you can call other functions within functions. Input is a function, and I'm calling it from within the getInteger function. So again, theoretically, you can have as deep a call chain as you want. Again, yes, technically, there is a limit. You will have to work very, very, very hard to reach that limit. So effectively, do not worry about how many functions you are calling within functions. You will be fine. Now, I mentioned at the start that one of the goals behind functions is to process information and return that transformed data. And the easiest way of doing that, and we will take a look at other ways later, is to use a return statement. When you hit a return statement in a function, that will immediately terminate the function. It doesn't matter whether it's down here on the last line of the function or somewhere inside the function. It doesn't matter. If you hit a return statement, that function is done. It's clocking out. And whatever variable is inside or is after that result, or words, whatever variable is after that return statement, that is the value that will be returned out of the function. Now, a function doesn't have to have a return statement. If you look down here at our def main, and yes, I will be explaining these in a moment, the def main, in addition to not having any parameters, doesn't return anything. There is no return statement. It's just when it hits the end of the function, which is this line here, that's it. It stops execution and returns the execution back to whoever called it. Now in this video, I'm going to show some variations on where we put this return just so you can see how it works. Well, let's start talking about what this sample program here is doing. And I want to start off with the bottom two lines here. If double underscore, and that is a double underscore, by the way, if double underscore name double underscore is equal to the string double underscore main double underscore, call the main function. What am I doing here? This is why I said do not use underscores, and especially do not use double underscores for your variable names. They have special meanings in Python. There's a whole list of these predefined values that you can look at in Python. The most important one, and the one that we're going to deal with pretty much exclusively, is double underscore name. This gives you the name of the module or the file that you are currently in. Not, I shouldn't say file, that is incorrect. Just the name of the module that you are currently in. By default, the module that is launched, let me just hit a quick F5 here so we can see this. So here, I mean, it's a gargantuanly long launch statement, but this statement here is using Python to launch this file. By default, whatever file that you launched, whether it's through an excessively long thing like that, or it's by typing Python and then the Python file that you want to run, that is going to be your main module. It is your entry point into the program. That will always have the double underscore name of main. And so a very common thing that you will see in Python programming is you will have a def main someplace. The actual name of this function here is tradition. It's not mandatory. It's not required to be called main. You can call it supercalifragilisticexpialidocious if you so desire, though I recommend against it. That's a lot of typing. It doesn't matter. This function name here is irrelevant. But by tradition, it's called main. And what you will see is the only two lines really that gets executed automatically is going to be this if check. If our name is main, in other words, this file was used to launch the Python program, then I am going to call the main function. And so what happens is that this is going to be true. We'll hit this line. And then flow of execution is going to jump up to here. It's going to jump up to line 20. And it's going to start executing. So it's going to execute this line. Oh, whoops, we have another function here. So now it's going to jump to line 3. And to show this, I am going to introduce a debug tool. If you, and this is very specific to Visual Studio Code, by the way, how you do this in other applications will vary, but it's mostly the same. In that if you mouse over onto the left edge of your line numbers, you will see I have a little red faded dot following my cursor. If I click, and it gives me a pop-up tool here, click to add breakpoint. If I click, it turns to a bright red dot that stays even after I move my mouse cursor off. This is what we call a breakpoint. What will happen now when I hit F5 is the flow of execution is going to break as soon as it hits this line. You can see a highlight here telling me that, okay, I haven't executed this line yet. This is where we are. And then up here at the top, I have a variety of tools. The two that we are mainly concerned about are step over, F10, and step into, F11. Step over says if there's any functions in here, just execute them, finish executing them, and continue on. Step into says if there's a function in there, I want to see it. So what I'm going to do is I'm going to hit F10. Now I'm on this line here, and now I'm going to hit F11, saying if there's a function, I want to step into it. Oh, I've stepped into it. Now I'm going to hit F11 again. And now I'm up here. Pardon me. F11, F11, F11. Now here I don't want to actually step into input, so I'm going to do an F10. I need to put in an integer. Again, I don't want to step into the isNumeric, so I'm going to do an F10. And we'll go through and talk about this isNumeric stuff here in a moment. As you can see, the flow of execution, I'm just normal execution here. Again, we finished off our if statements, so we're jumping back up here to the while. Valid input is now true, so this isn't going to be correct. So, and again, I'm hitting F10s now because there's nothing else that I really want to jump into. So I'm going to hit F10. We're now going to return result. We're now back to this line because we finished our function. Hit F10. And sure enough, x is 3, which is the value that I put in. Again, I don't want to hit F10 again. Now I'm back here. Hit F10 again. Execution is finished. So again, the core point behind that is when you call a function, you will jump to the first line of that function, execute every line in that function, and then once you're done, it will return you back to where you called it. So we call main, jumps us up here. We call getInteger, it jumps us up here. Once we are finally done and we return result, it returns us back here, and now this function is going to evaluate to whatever result was, whatever we returned out of it. And then we execute this line. Oh, we're done with the main. So now we return here. Main doesn't evaluate to anything, so we didn't return. And now the program is done. Another way of visualizing that is I'm going to put in a couple of extra print statements here so we can see the flow of execution. So print before main. I'm also going to put in, after the if statement there, print after main. And so what we would expect to see is we should see before main, then we should see our prompt to enter in the number. We should see the result of multiplying that number by 2, fix my spacing, and then we should see after main. And just to also help, let's put in another print statement here. Done with input. Hit F5 to run this. So before main, as expected, because that line got executed first, we call main, we call getInteger, we come down here and we are now on our input with our prompt message, give it a number. Then we are done with input. We print out the number, and then we print out after main. I'm going to go back through and remove those print statements because I just put those in to help visualize the flow of execution. And that's functions, like that's how they work at their core. One last thing on functionality. Return statements. I mentioned at the beginning that I can put a return statement anywhere inside of a function and that will instantly kill it. For example, if I put a return statement here at line 6, that would not be a good idea, by the way. I'm going to say return 0 right here. Now, notice that Visual Code is trying to help me out here, and as soon as I put that return statement in, all of this other code got faded slightly. That's Visual Code's way of letting me know. It's like, user, based on what I'm seeing right now, this code is unreachable. This will never be executed, which it's quite correct. If I run it now, it just prints 0. Doesn't prompt me to enter in an integer or anything. It's just 0. As soon as you hit that return statement, function is done. Now, does that mean that the only place you should ever have a return statement is the last line of the function? No. There are perfectly valid reasons as to why you would have return statements inside the body of a function. I would strongly advise, however, especially as a beginner programmer, there are exactly 2 places that you should put return statements unless you are very confident in what you are doing. You should put your return statement as the last line of the function, or as like the second or third line of the function. In other words, you've got some sort of like conditional, like if this condition is false, I don't want to do this function, so return out. So I would strongly advise that as a new programmer, try to adhere to that rule. You return 1, at most 2 return statements in a function. Again, that is a guideline. It's not a hard, fast rule. But as a new programmer, I do strongly advise you follow it. Okay, now what exactly is going on in this particular code sample? Again, I've already covered the def main part, but I'll just review it over again real quick because you will see a lot of Python programs structured like this. If double underscore name is equal to double underscore main, then call the main function. In other words, if this file was used to launch the program, call the main function, so that way we can get things started. And then main does whatever it does. Is this complete absolute overkill in this particular scenario? Yes, it is. But I just wanted to present it to you because you will see this in Python code. All right, the more interesting one is the get integer from user. So we've been getting input from the user and just immediately casting that input to an integer value. However, as I'm sure you have found out through your testing, if you try and do that to a string, so in other words, if I say x is equal to int meep, no, whoops, put it after. There we go. Exception has occurred. You will get an exception message, you will get an exception error if you try to cast a non-integer to an integer. Makes sense, but we don't want our programs to crash if the user gives us a bad value. There's a couple of ways of handling that. For this solution, I am doing the simple way of handling it. So I know that I want to get an integer from the user and that there's going to be a sequence of steps. I'm going to have to get the input. I'm going to have to validate that the input is an integer. I'm then going to have to cast it and return that value back out. Otherwise, I need to print an error message to the user saying that's not right and do the process again. So I've got this sequence of steps that I'm going to have to repeat every single time I want an integer. And so if I'm doing this 50 times throughout my program, I don't want to have this block of code embedded in 50 different places in my application. That would be a nightmare to try to maintain. Like if there's a bug in here that I don't discover until after I've inserted it in 50 times, now I have to go through and try and correct all 50 instances. And if I miss one, I've got a really nasty bug that's not going to show up until I hit that one that I forgot. No, nightmare scenario, do not want to do that. So I need to have all of those steps in as a function. And I do want to have I don't know if my cat just came across. I apologize if he did. So I know there's like, in order to make this generic, I know I just said code reuse. Do you almost never use it? This is one of those few scenarios where, especially as a beginning programmer, like, yeah, having a little function to do very basic validation on getting an integer is kind of useful to have around in Python. So what I want to do is I want to, for this function, I know it's going to return an integer to me, but I'm also going to pass in, how am I going to prompt the user? Am I just saying, give me an integer, please enter a positive number, please enter a positive number between something and something, whatever I want to prompt the user here. Now, there could be a lot of different ways I want to say this. So I'm going to pass that in as a parameter. So that way I can have different messages. And then when they give me the invalid data, how am I going to tell them? Am I going to be polite about it? Am I going to insult the user? Don't do that. Don't insult your users. Now, how am I going to, let the user know that was an error? I don't want to see that again. Well, I can pass in, again, I'm passing this in. And you pass things in the order that they are listed up here. So prompt message gets the first value that's passed in. So this becomes my prompt message. Error message gets the second value that's passed in. So it gets this value. Now the logic here isn't too complicated. I'm going to initialize my result to a starting value, 0. We always want to initialize our variables, even when it's not strictly speaking required. The result equals 0 is not strictly speaking required. The valid input equals false is required. That is needed to prime my while loop. So as long as I don't have valid input, I want to continue doing this loop. So valid input is false, so I'm going to immediately fall into this loop and start executing. I'm going to get the input. Notice I am not casting it here. I am getting the string of whatever the user is going to give me here. So whatever string the user is going to give me, stop being helpful code, I want to keep that as a string right now. I don't want to try to cast it as a number because it might fail. All strings have the isNumeric function. So I can say variable name dot isNumeric, and as long as it's a string, it will tell me, is this a positive integer? And it is that specific, unfortunately. It is a positive integer. If there's a negative sign in there, that's not a numerical character, so therefore it would fail this check. If it's a floating point, it will fail this check because a period is not numeric. This is very, very specific for checking to see if it is a positive integer. So if this is true, if temp is numeric, then we will then do the casting. So we're going to cast temp to an int, store it in result. We'll set our valid input to true. We always want to remember to put in our loop kill condition. We won't do the else because the if was true. We'll loop back up to the while loop. Valid input is now true. So then we'll skip back down here to the return statement and we'll return whatever number the user gave us. If isNumeric fails, they put a letter in there, a negative sign, a period, whatever. Then we'll get the else. We'll print out an error message. Since we didn't change valid input is still false. So when we loop back up here to the while, valid input is false, and it will continue on. And we can see this in action. If I put in anything besides numbers, it won't let me continue until I finally put a number in. And that is it for the introduction to functions. As always, remember to check the W3 Schools page on functions in Python for additional reference material. And with that, I'll talk to you in the next video.